Okay, by converting to from logarithmic form to exponential form, calculate the value of t if. Okay, two logarithmic expressions. I don't immediately see where they're going with these, but as a general rule, if you can get rid of some logarithms, do it. It almost always makes things clearer. So this is a logarithm of base 2. I'm going to change it to an exponential of base 2. It'll be 2 to the third equals x. The base stays the base, and the other two numbers trade places. And for this other one, it's again logarithm base 2, so we get 2 to the x equals t. All right, 2 to the x equals t is still kind of a mystery to me, but this we can actually do. We know 2 to the third is just a number, so let's not leave that looking mysterious if we don't have to. 2 to the third is 2 times 2 times 2, which is 8. Okay, that's progress. X is 8. Now we can put in 8 over here. 2 to the 8th power equals t. And of course we all know our powers of 2. 2 to the 8th power is 2, 4, 8, 16, 32, 64, 128, 256. There we are. Now, I guess this is a similar thing. Let's just change it into exponential form, and we'll just trust that that's going to help. Logarithm base 5, so we get exponential base 5 to the 2 equals x. I might as well solve this right now. X is 25. If this were like 5 to the 15th power or something outrageous that would be hard to write out, and too big to fit on the calculator, quite possibly, then I would hesitate to evaluate it. But if it's a number that you could count to, if it's something that's only 2 digits or maybe in the low 3s, I'd say evaluate it. It makes things simpler. Over here we have a log to the base t, so we're going to have an exponential base t. T to the minus 2 equals x. Well, we know what x is. T to the minus 2 is 25. Okay, so that's good. We're down to one variable now, which is nice. We solved for x, and now x is going to help us find t. How do we get rid of this minus 2, you remember? Here's a hint. If you want to strip this off, you use its reciprocal. The reciprocal of minus 2 over 1 is minus 1 over 2. And as usual, we must do the same thing to the other side as well. So those exponents kill each other. We get minus 2 over minus 2, so it's just t to the first power equals. Now what does this mean? Three things going on here. We start with 25. The minus says do its reciprocal. The 1 says put it to the first power. Well, that's a bit of a waste of time. Everything's to the first power. And the 2 means square root it. So starting from 25 to the minus 1/2, that gives us 1/25 to the half. That's the reciprocal done. Put it to the first power. That's pointless. That leaves us at 1/25. And then we do the square root of that, which is plus or minus 1/5. The square root of 1 over the square root of 25. So, two answers. Are they both good? They aren't, and it's for a reason we've seen before. If t is negative 1/5, that's illegal up here. The base of a logarithm cannot be a negative number. And so we have to discard that minus 1/5. It's what we call an extraneous solution. The only number that actually works is plus 1/5.